All right. Welcome back, everyone. I think we're going to jump right on to the next talk by Joscha. This is the last session for the day. There's only going to be one talk on one stage. So if you know anybody who's on stage 2, ask them to come over to stage 1, and let's get started. So I'm happy to sort of welcome Joscha to Breakpoint. Joscha is going to be talking about visual regression testing, the why, the what, and the how. He's been the tech lead of the developer platform group at Canva and has been tasked with engineering productivity for their 500 plus engineers. Joscha and Canva have been using Percy as a vital part of their front-end engineering at Canva for the last few years. Great, Joscha, I'm going to hand it over to you.
Yeah, hi. Thankfully, it's not only been me that has that developer productivity has been handed off. We're actually almost 35 people that do this together, and our team is tasked with all of it. Let me try. Am I good to reshare my screen now?
Yes.
All right, cool. Let's do this again. Small pop-up and full screen.
Yep, looks good.
Yeah.
Oops, I lost it.
Oh, did it kick out? Oh, yeah, my button came back. Hold on.
Yeah.
Are we back?
Yes, we're back.
Okay. All right. I want to say good morning, but I don't actually know where everyone is. I'm in Australia, and it was 4 a.m. when I got up. I have the last slot, so thank you very much for giving me the last slot and make it a little bit easier. But I am quite tired. I hope I'll be doing a good job, and I'll give you some information about visual regression testing. My name is Joscha, and I'm an engineer at Canva. Canva is a design platform for the browser, and I'm part of the developer platform group at Canva. We're 30 plus people, and our primary customers are actually our engineers. And it's our job to provide a world-class development workflow, and it also includes visual regression testing, which is why I'm here today. Just so we're all on the same page regarding VisReg testing, because it's a fairly new field, I want to do a short intro so we all know what we're talking about. Do you remember this from being a kid? It could be a page in a magazine or a newspaper or some comic book, and it's got a very noisy image of it. And there's 2 copies of the same image. And the second one actually has 10 differences to the first one. You got to spot them. This particular one that I picked out is from a German quiz website. And you may or may not have noticed that I actually switched out to the second image whilst I was talking. So potentially you've already seen a couple of these differences. If I enable animations on that picture, you should be able to see about 7 or 8 of them fairly easily. And I want to highlight a couple more because these are much harder to detect, even with animation. And which ones you can detect and which ones you cannot detect, it really depends on you personally, like what you pick up on how your mind is wired. And I've highlighted the ones that I missed initially when playing the game. They're fairly subtle, at least to my eyes, they're fairly subtle. And Percy is actually in the business of making such very, very subtle regressions visible to you and your team. And it does so via comparing a new iteration of something against a known baseline from before. It's like any other snapshot that you know from like your jest tests or any other unit testing suite. We're currently looking at the baseline of the image in Percy. And then once we send Percy a new iteration, in our case, the second image with the 10 differences, it actually displays you the regression as a visual diff. And you can see that there's 10, or there's a little bit more than 10 spots because it alternates in some places, but there's 10 spots that basically show how the image changed from one to another. And obviously, solving children's games is an excellent use of a service offering, but luckily for Percy, there's a little bit more to it. To understand better at why this might be useful outside solving kids games, I would love to have a short look at how, like a very simplified look at how this magic works. First, you create your JavaScript, your CSS, your images, etc., everything like you're used to. And then that particular web page gets rendered locally in a headless browser. It then takes, like Percy provides a CLI tool, and that CLI tool then takes the assets, like the things that you've produced earlier, plus the snapshot that we've just produced, and some metadata from your version control system and uploads it to the Percy side. And then Percy renders it on their side in Chrome or Firefox, potentially multiple widths, in right to left languages, and it compares it with a baseline that you gave it earlier. And if the baseline comparison displays a diff, like we've seen earlier, like the 10 differences in the images, then it displays that diff to you, and it updates the commit status on your pull request, and allows you to look at the diff and say, oh, okay, this looks good. I want this to be my new baseline, or no, this doesn't look quite right. I need to make more changes to my code in order to reduce the diff, or maybe increase the diff if you have missed something that should have changed. So why did Canva become interested in this? The easy answer is that we had a testing gap. Don't we all have a testing gap? I feel everybody has a testing gap somewhere, but we had a really glaring one in this case. We did have our unit tests, and we had unit tests for a long time to test like the smallest parts of our system. And then obviously we had integration tests where we take these units and combine them to functional tests. And in addition to these functional tests that we would run on a separate platform, we also had end-to-end tests where we would use our real backend services in order to have a full go through the whole Canva application. But none of these tests work very well for visual regressions. Visual regressions testing gives you high confidence, especially for sweeping changes in both directions, to make sure that intended changes are reflected, and also to make sure that unintended changes are detected before they get shipped to the customer. And Canva is highly complex, and we work preferably with composition. So we're using building blocks that we recombine everywhere. That works generally quite well, but there are some languages, as we all know, which have only very rudimentary isolation built in. You've probably seen this meme before, and it shows exactly why functional testing can't always catch things. Some regressions are just not functional. They're purely visual. So a functional test has no chance to catch them. Have you ever had that false positive where a Selenium test would pass because it was able to find that 2x2 pixel button floating somewhere? I think we all have. And it's really easy to miss these things in tests for real humans, where the Selenium tests or your automated test suite, it doesn't have to be Selenium, does not miss them because it can find them via other means than purely visually. Now, obviously, Percy hadn't always been around. And before we had this category of errors as well. So what did we do there? We obviously did manual testing to mitigate. It was very, very manual indeed. We had 5 different browsers. We had about 15-ish scenarios. And they were manually tested by different testers in different browsers in parallel. And the whole process was fairly long. It was like a 3-hour average. And these tests, they didn't only test UI, but they also tested UX, they tested new features, they tested bug fixes, etc. And visuals were part of the QA, but they weren't only done exclusively. So it was very easy for the testers to miss UI changes and all the craziness that they had to test before something went out. Also, Canva has grown a bit. It is actually close to impossible for any one person right now to know the real expected state for each of the parts of Canva. The manual process worked for a really long time, but around mid-2017, it became quite tedious and brittle. And there was that one inflection point where we really couldn't do manually test anymore. Permutations of the same code resulting in differences, often visual, that was the inflection point. To name only some of the axes of these permutations, there were multiple locales, including right-to-left languages, multiple screen sizes, multiple groups, like we have, for example, a product for education, a product for enterprises, a product for charities. We obviously use multiple browsers, like any other web application, and we do have feature flags that we switch on and off based on experiments for particular user groups. And with our engineering growth, only automatic testing can scale long-term. And if it took around 3 hours in 2017, where we had around 30 front-end engineers, can you imagine doing manual testing for code produced by 260 front-end engineers? Yeah, me neither. It would take a crazy feat of manual testers. It would take a really long time. You could forget about continuous deployment and else. So what did we do to leverage visual regression testing for our benefit? Basically, we applied a concept to our UI that we all know from unit tests. We try to make the thing under test as small as possible. In order to do that, we split components into really, really small parts. I picked one out here. It's just an example. It's just one of these components, but it's very, very nicely split up so you can understand it easily. There's a selector component for a tabs component. There's a store that controls the state, like which tab am I on. And there's a tab content component that displays the content of the tab that is selected. The component itself has no visual representation, but only behavior. It has caching, it has deferred loading, and so on. And we test this component via unit tests and, if needed, functional tests. You can see a representation of the component here, but this is not the thing that we run through visual regression testing. This is just a sample for somebody to click through and try out the functionality, or potentially a functional test. That working base that we have is then extended and made visual. There's no surprises here. You can very clearly see a tabs component, I hope. And it does use the tabs base component from before. Another two variations of the same component you can see here, they don't immediately look like tabs either, but in essence they are. All of these have their own story in a tool called Storybook that we use really extensively. So functionality, performance, and so on is tested on the base component, but the styling is tested on each of these compositions via visual regression testing. All components are in there without fail. We have atoms like colors, font stacks, metrics, which are basically numbers. We have like a grid baseline number that you can reuse. We have a border radius number that we can reuse. There's some base components in there, like the tab space component that I showed you. And there's also composite ones, like the ones extending tab space or combinations of multiple components. If you look very closely, I highlighted it with red, you can see a small IS Unicode behind the story name. That is our marker in Storybook for what is actually visual regression tested. Splitting components like that results in a very high number of visual tests. In the slide, you can see a progression of our VisReg tests in Storybook from 2017 to last week when I prepared this presentation. We're at almost 3,800 unique VisReg tests in Storybook, with another around 1,100 stories that are not tested in VisReg. That is close to hitting the 5,000 stories tests across all of Canva. That is a crazy number, but fear not, they're expressed uniquely in Storybook to keep our code structure clean and maintainable, but they're not necessarily rendered and tested uniquely. I'll touch on that later. Now that we talked about atoms and compositions, we also want to talk about our biggest composition, the Canva editor, the thing that you call the app. Literally the whole of Canva is in memory there. It has interaction with in-memory services only, and everything is in there with the exception of the server interactions. So for example, you can't do any real exports that would require a PDF rendering engine. This thing is the base for our local development and also our VisReg tests. So we can pretty much bring up the whole of Canva inside that headless browser that we were talking about earlier, change states, etc., and take snapshots when we want to. We use this fake mode to configure different permutations of Canva, the ones where I showed the X's off. An obvious one that we've talked about already is that Canva is not only used in English. So one of the things is that we want to test internationalization. And we do use a concept from Google called for that. We do use a concept from Google called pseudo-accent for that. Pseudo-accent embeds additional Unicode characters in the source translation string, and it pads it out by around 25 to 30%. It makes also sure that the full line height is used. And that gives us a chance to catch some things in visual regression testing. For example, non-existent line breaks where words or sentences are cut off, missing overflows that result in clipping or overlays, and components with hard-coded dimensions that don't adapt well to more text in English. Sounds familiar? Yes, these are all visual things, and they can't easily be tested in any other means. We also have a couple of other languages that are great at detecting problems with our UI. In the past, we used Thai in Visrec as one of the specialty languages. Thai is great for ascenders, but we actually recently switched to Burmese, as it has both ascenders and descenders and wide letters in addition. And as an added bonus, if you tampered with Unicode anywhere, you'll know via tofu boxes instead of glyphs that show up in Visrec. We also have customers in right-to-left languages as well. We, for example, have Arabic and Hebrew, which we do use for user testing. In development, we cheat a little bit and run English from right to left. It's a very alien concept to most people not having grown up with right-to-left languages, so we do help our engineers to understand it a bit better. And you'd be surprised about how many people get utterly confused when they can neither read the language nor follow the direction. And Visrec really helps us to not miss things like wrong starting points, UI elements showing against the text direction, and so on. One use of visual regression testing came actually long after we had adopted it for the obvious regressions we have been talking about. In a graphically and interaction-rich application like Canva, we started seeing things that are conventionally untestable with other methods. Untestable as in assertions for things that are almost impossible to express as a unit test or integration test. For example, transforms in our canvas, like when you rotate an image, SVG normalizations, auto-generated shapes, or on the far right, you can see perspective transforms for our print preview, where a design of a customer is actually shown on a billboard or similar. And we can render these with our fake mode in visual regression testing and make sure that the overlay of the billboard fits perfectly and so on. Did someone say animations can't be tested? They sure can. We have a global flag for animations to enable and disable them. Animations are actually a first-class property of all of our UI components, and every single UI component has to respect it. If animations are switched off, no animation classes are applied, and thus no transitions, etc. are run. It happens automatically for CSS-based animations and transitions via best practices. Here in this slide, you can see a decomposition of the states of our upload animation. If you don't know it, our upload animation is actually a little fishbowl with like a wave that changes and moves. And if somebody accidentally affects the choppiness of the wave or breaks the animation with a refactor, it would show up here because you'd get a visual diff of the waveform. So what do we do with graphical state changes? Pretty much everyone has these. Canva has potentially a little bit more of them. And in a design tool, we have also quite complex one. I have added them on this slide as an example, and I hope you will be able to see the little pictures pop in. That is one of the things where you can use the animator to automatically add animations to design. This design that you're currently looking at, that I'm presenting, is actually made in Canva. And so you can actually see in the slide, it's a little bit inceptive. You can actually see in the slide a sample of a design with green boxes as well. And we can define the state for visual regression testing by separating configuration and a custom script setup to kick the animator component into the right state. And then with different timings, we produce different snapshots. And the setup for this is actually really easy if you know ahead of time. And Visrec can really take away the brunt from conventional fixtures. You will know when you need it, and you'll probably or hopefully remember this slide. A similar example is in Storybook for our particle system, where we freeze state and then run visual regression tests on it. So if somebody accidentally breaks the particle system in a refactor, we'd see some broken hearts here. That was my dad joke allowance for the day. I apologize. Now that you've seen what we test, let's talk about how we make this happen. You've already seen a glimpse of it in the examples, but let's look at some of them in a little bit more detail. Let's start with a super easy one. We actually use a checkered background for our storybook that is automatically enabled via CSS when running in Visrec mode. The pattern will only take you a few minutes to set up, but it will massively increase the chance to detect accidental backdrops, background changes, margins, paddings, and even shadows. Especially if your application has both a light and a dark mode, you can miss things if you just pick a white or a black background. The checkered pattern is really a very, very small trick that you can use, and it has great impact on how you can see diffs. Equally simple, but effective, as you've already heard, we test our animations via Percy for components, but we also disable them by default during visreg for all of our components. Percy actually has some built-in code to prevent animations, but depending on how you do animations, and there's many, many different ways to do them, it might not always work out. We at Canva have a global configuration flag that these UI components respect and use, and it's actually hooked up to a storybook knob, so we can toggle it outside visreg. By default, animations are enabled, so during normal development, the component feels natural. But during visreg, we switch it off, so animations don't produce diffs. Another one of our key ingredients for our development environment, you heard the fake mode, both for the fake mode and our storybook actually, is randomness. We use randomness almost everywhere. We have stable random service responses for our fake services. We use random avatars, random avatar names and billing. There's random dates in there. Those are especially tricky. And there's also random lorem ipsum text that changes in length, number of paragraphs, etc. And we do this mostly to make sure that engineers aren't cheating timings or dimensions accidentally. And we do it so most edge cases are caught during the normal development workflow already. Our fake mode behaves as real as possible with this randomness. However, having that randomness everywhere comes with a little caveat. You actually need to control it in visreg. Otherwise, obviously, you'll get many, many diffs based on that randomness. And we do control it via seeding the randomness. It means that there's still randomness, but the sequences are stable. So when Percy looks at something, even though the data itself is random, Percy always sees the same random. It can be a bit tricky when global sequences are used alternatingly, but thankfully there's a very easy fix. You can just inject the random generator instead of using a global one, and then seed each use individually. I also want to mention a tool here called faker.js. It even comes with a small microservice. We don't use it at Canva. We discovered it a little bit too late, but it looks super impressive. And by the way, the in-Percy function that you can see in the screenshot on the right is actually provided by a package from the Percy team. So you can just import that and use it. You don't need to write it yourself. After talking about very specific things you can do to make visreg testing a success, I also want to give you a little bit of advice on scaling on the last slides. The biggest one is nip flaky tests in the bud. And I want to say it again, nip flaky tests in the bud. It does seem like an obvious one. We wouldn't accept flaky unit tests, for example. But as testers, we do unfortunately often accept flaky integration tests. And the harm of flaky visual regression tests is very similar to the one of flaky integration tests. So my advice is keep them as stable as possible. An example, UI components often measure on the client side. And then measuring can trigger a second render, which can then cause a race condition, and it shows up as a diff in Percy, as you can see here. Another one for us, engineers have not respected the animation flag, and then these animations can show up as diffs. It shouldn't pass code review, but we know it sometimes does. At least they're easy to detect. Thankfully, a rare one, but still worth mentioning, font fragment diffs can appear if you've used a dynamically loaded font, or if you have some reflows in your initial render. There are some measures in place from Percy which will actually catch like 95% of these issues. But if you do some exotic things in Percy, they might need a little bit of extra help. And if you see these font fragments, try to use a local font for visreg. It might fix it. And if you can't find it, reach out to support. They actually have great knowledge and skill at solving these. In any case, if you don't fix these fast, then the baseline will flip-flop between states, and people will see diffs all the time. They will become frustrated and start ignoring visreg, or just approve anything because they're like, oh, it's just a new baseline. I'm gonna get it into master, and then the next person does the same. And finally, sometimes these diffs that we see in visual regression testing is actually things that users can see as well. They can see reflows, they can see remeasures, they can see re-renders. So fixing them in visual regression testing will actually make your application more stable for customers as well. Don't worry too much about flakiness. Controlling it is possible at scale and not too tricky. It's definitely not as tricky as controlling flakiness for functional tests. Talking about scale, however, when you do grow your test suite and adopt visreg wholeheartedly, you will end up with many visreg tests. And divide and conquer is your friend as always. let me give you two things on the way that will allow you to reduce the number of regression test runs. Canva runs about 14 million a month. So even if you hand select them, you'll end up with a few, and most likely more than you actually need to run. That massive amount can be really hard to review, and it can also burn unnecessary resources if things don't change but are tested anyway. And independently of global warming, it will also help your spend if you test very little. At Canva, we added an additional API layer on top of Storybook that allows engineers to define whether a story is tested in VisRig or not. So the engineer creating the UI component can create as many stories as they need to showcase anything for human interaction, and then mark a subset of those stories or add additional stories for automated testing. Remember the eyes Unicode that I showed in the screenshot earlier? That was such a story that was especially marked for automated testing. So when an engineer is using the add with VisRig function instead of the standard add function from Storybook, that's when we mark it for visual regression testing, and that's when we add this little eyes emoji to it. In addition to making the engineer think about meaningful, or tester think about meaningful visual tests, we make use of the dependency graph of our repository to automatically find out which visuals have changed in pull requests. We do this by calculating changes between the current commit and the last time a baseline was produced. We track this information inside Git as a branch that we forward whenever we produce a new baseline. And then our dependency graphing tool can calculate the changed files and print stories that were affected by any of these changes. If there's no changes, we don't need to do a VisRig build at all. If there's some changes in some of the stories, we do a subset of the visual regression tests. And Percy actually has first-class support for this. You can tell Percy, oh, by the way, the current build is not a full build. It only is a subset of the stories that I want to run. And finally, if all of them affected, then you don't have a choice. You just need to run the full build. Lastly, it wouldn't be a real presentation if there wasn't some conflicting advice. Combine some of the VisRig tests in one. This will allow you to test multiple related components in one snapshot. The advantage, the overhead of spinning up a browser, etc., is only done once, and you make really good use of the already invested time. We actually combine stories automatically and then allow opting out for stories that need the full screen real estate. That way we can test multiple VisRig stories in one snapshot. There is a little catch to it, of course. If a change causes a reflow in stories further down, then the resulting diff may be harder to understand than if it were all in separate snapshots. So choose a middle ground that is right for your application. For us, this is a folder in our repository, for example. The last thing I want to talk about, because it always comes up, pricing is a little bit more competitive than for other dev tools, but the reason is the very high level of abstraction. So it's probably not going to be the cheapest tool in your chain, but one totally worth it. 100% I guarantee you will get a great result. And to give you a few reasons on why Canva does not have engineers create snapshots on their machines like 10 years ago, we don't actually want to maintain a VisRig tool or stack. It is a full-time job. There's lots of small things that you have to look after, and you have to control all of them in order to provide a meaningful experience for lots of engineers. And we want easy and stable baseline updates, especially independent of the local machine. I've worked at a company before where we had our own tooling set up, and you would create the baseline on your machine, and pretty much whenever there was an update in any of the dependencies, you'd have trouble keeping it completely stable. And multi-browser support is also something that is important. And we want recent browsers, and running multiple browsers over multiple versions over a very long time is also a full-time job. Finally, multi-project support. This is probably one of the most important ones. For us to be able to scale and to have teams being independent from each other, we actually need multiple baselines. And Canva has around 100 of them. I counted it last night. And then finally, the responsive support. This is a little bit ambiguous. I'm talking about both the browser responsiveness and the support responsiveness here. And once you have all of this, there's still one last bit that kind of makes it or breaks it, and that is the toolchain integration. At Canva, we use GitHub and a pull request flow, and we use that very, very extensively. And Percy, for example, integrates really nicely with our flow because it uses the pull request, it uses the data, it uses the metadata from it, and it also updates the checks in GitHub, for example. All right. I hope you were able to take away a few tricks or hints to make Visrex better for you in the future, or maybe I could convince you to start up using this testing strategy. In either case, I wish you good luck in your Visrex venture, and if you have any questions, please participate in our QA session. Thank you very much for listening.
Awesome. Thanks, Joscha. That was great. I think it was pretty amazing the level of scale Canva has hit with your visual regression testing. Quite a few questions here, so let's see if we can try to address as many of them as possible. Okay, first one is around mobile testing. So how do you account for mobile browsers and sort of Canva on mobile?
Yeah. So for mobile testing, we have multiple testing strategies. We do run functional tests on real mobile devices, and we use a device farm for that. Like, we don't have to test ourselves. And we also use the same functional test definitions to run mobile testing in emulation mode. So we use like a Chrome that we basically tell you're an iPhone 6. And these two testing strategies, they catch a lot of things. But Percy actually, in terms of visual regression testing, which is why we're here and which is part of the testing strategy, you can actually define the screen width that you want to test at. So if you have a design or a component that responsively adapts to the size of the screen that it is rendered at, then you are actually going to be able to set up your own tests in Percy for it. And I haven't shown this. Maybe I should have shown a screenshot. I'll take this as an improvement for next time. But you're actually able to define your stories once and then give it multiple widths that you want to test it in. So you can easily, and you can also define some default widths. So you can say all of my snapshots, independent of how they are defined, I want to render them in 1,000 pixels and 100 pixels. And then each of the engineers can actually make up additional breakpoints as well, and can say, in addition to the default widths that you have, like the 100 and 1,000, I know that my component in particular, it behaves differently on an iPad in landscape mode. So I also want to test a 500 pixel width. And it would show up in the Percy screen as different tabs that you can switch between, and it will show you the pictures, and it will diff each separately. So it will produce 3 pictures for the baseline if you have 3 different widths, and it will compare each image of the baseline against the image with the same width from your current branch. So you'll see 3 different types of diffs. So does that make sense?
Got it. Yep, makes sense. All right. Next question is, a lot of times when you're testing a web page, you might have pop-ups or messages that are coming in, changing the page height because it shows up on the top and it pushes the page down. So that could potentially corrupt your baseline, right? In the sense that it's something that's temporary, that comes up. So how do you account for those kinds of things when you're doing visual testing?
I don't know if I completely understood. Is this about an accidental change that pushes the rest of the page down, or?
It could be It could be like a promotional message that comes up on the top of the page, which pushes the rest of the page down. So it's like a temporary thing, or some sort of announcement that you're making on that particular page. Okay,
so we do control, we actually don't run, and I know you can do this. You can run Percy against a live website. We don't actually do this. We don't run Percy against a live website. We use the fake mode that I introduced in one of the slides, which is basically the full Canva, but in a controlled environment. And we do control very tightly what features are enabled and what features are disabled. And we do this per snapshot. So the chance that there's a pop-up appearing out of nowhere because somebody else defined an experiment outside of the code is close to impossible. Like, it's really hard to do it. We obviously test experiments as well. So you'd make up a separate story to test the experiment, and that would have the banner as the only story. But just to give an answer, in case you were doing a live testing on a page where something like that happened, ideally you would want to control it as good as you can and make sure that Percy is as stable as possible. But if such a banner were to be displayed, then Percy actually detects it detects a similar diff on multiple pages as part of the same project. So let's say you have 100 pages that you test. They're all your website, and the banner would show up on all of them. Then Percy would actually detect that this change is the same for all of the snapshots, and it would show you an overview. Like you don't need to accept every single of the 100 separately. You can actually you will actually be able to see, okay, this is a recurring change. But when you accept them or when you run on master, you will create a new baseline. So once that experiment is switched off, or let's say you have a cookie of some sort that controls it, then obviously the reverse diff would show up where everything like switches the 20 pixel back up again. So the only thing I can recommend there is to basically make sure that whatever you test in visual regression testing is as stable as possible, and you have the state defined that you want to test. This is not any different from functional testing either, by the way. Like we have the same problem there. If you do synthetics test against a live system or something, you'll hate the nice upsell pop-up that shows up and overlays some of the buttons that you actually want to click on.
Yeah, got it. Okay. So speaking of functional testing, have you found that your functional testing or your functional regression tests have reduced because of the visual regressions that you're running with Percy?
No, they're not. They're really two complementary testing strategies. I don't think we've reduced our functional testing at all. If anything, actually, we do use it better in terms of what it's meant to be testing. So the functional testing really goes towards the interaction side of things, whereas the visual regression testing goes via the UI kind of things. There's obviously some overlaps. Like you can produce new states via clicks. And I know that like because you have you can run Percy on top of Puppeteer, you have full control of state changes. So you can mix and match them. Like you can say, click on this button, or take a snapshot, click on this button, take another snapshot, and then you'll see the pop-up that is produced by clicking that button, for example. This is possible. You can definitely do this. And there's even a WebDriver IO plugin that allows you to hook into the WebDriver IO lifecycle, where you can, for example, we use Cucumber.js. You can, for example, have a step that says, I produce a baseline, and then 5 steps later you say, I compare against the baseline, and so on. At Canva, we don't currently do this. We do keep our functional tests and our visreg tests fairly separate. I can name a few outliers there. We have a few, like the animator example that you've seen earlier, where you would probably call the change of timing a functional component, whereas the location of the boxes that the animator produces is the visual component of the thing. So there's definitely some outliers there where we don't completely separate the two, but for the most part, we use these as complementary testing strategies.
Got it. Awesome. All right. Another question, Joscha, is around screen resolution in testing. So if I understand the question correctly, I think it's about how do you prioritize the different screen resolutions for desktop and mobile?
What do you know what prioritize means in that sense?
I'm guessing maybe it means like how do you decide maybe which resolutions
how do you decide? Okay. So for Canva, I don't know if this is general advice. I can tell you how we do it at Canva. So we do actually have some meaningful breakpoints that our UI components respect. And those meaningful breakpoints, they're actually part of the metrics atom that I was talking about earlier. Like it is a number, and you can use this meaningful breakpoint in the component. So I'm making this up, right? I don't know what the exact numbers are right now, but let's say we have 2 breakpoints defined at 200 pixels and at 1,000 pixels, and all of the UI components know that these 2 breakpoints exist, and they actually read the number from the metrics atom. Then they would potentially look different when they are 199 pixels, 201 pixels, and 1,001 pixels. And so if you have these 3 numbers, then you know already that you have 2 numbers. That means you have 3 buckets of resolutions that you need to put tests in. So in Percy, you would say, okay, I'm testing at first breakpoint -1. I'm testing at first breakpoint +1, or maybe a little bit less fragile. I'm testing at halfway between second breakpoint and third breakpoint, and then I'm testing at third breakpoint +1. and that would allow you to give you confidence that you've tested every single component at all the breakpoints it supports. It does get a little bit more tricky when each of the components makes up their own breakpoints. For that case, each of the testers, like the person writing the component and the test strategy there, can actually define their own breakpoints. So Percy, you don't need to decide one particular set of dimensions for your whole Percy project. You can do it on a per snapshot basis as well. So if you have like 90% of the components having 2 specified snapshots, and you have 10% of the components that have random snapshots, random breakpoints, then you can have these 10% of components define their own sizings. And I don't know, like if prioritization is meant in the sense of which one do you test, I can only tell you your Visrec plan will come with a certain capacity, and use it. Like if you only use 10% of your capacity and you have 20 tests, double them by adding more resolutions. Like obviously only if it's meaningful, right? Like if you don't have any responsiveness, then you don't need to test a second resolution. But if you do have it, then use it. And an extra. So the measurement of use for visual regression testing is the snapshots, because that's the part that takes a lot of computation time, right? Producing the image and comparing it against the baseline. So this is usually the measure of cost for visual regression tests providers, and that means that each of these decisions that you make, like the things that you want to test, it will eat into your allowance of capacity that you have. And so let's say you have one visual regression test, and you test it in one browser. That's one image. If you add a second browser, that's 2 images. If you add a second resolution, that's already 4 snapshots. So it doesn't scale linearly, because you obviously need to test all the permutations. So usually, what I've seen in the past is that most of the time you have more ideas on how to test than the capacity that you have, because if you add right to left languages into the mix and all sorts of other things, then the number of tests that you need to run, it really explodes. We've lost Praveen.
Sorry, I'm back.
You're back. Yeah, good.
My bad. Okay, great. Thanks, Joscha. I think we're almost out of time. But thanks a lot. I really appreciate you getting up early or staying up all night. I don't know what you did, but
no, I got up early. Yeah, thank you for having me. It was great.
Yeah, thanks a lot. Have a great rest of the day.
Take care.
Thank you.
Bye, everyone.
Bye.